Okay, let's go ahead and let's get started, folks. Hopefully, you're able to work out a few. I'm still in the process of putting together a set of practice problems for you to do with what we've covered so far in terms of how we describe motion. I'll have in that packet for you, in that practice packet for you, practice interpreting graphs as well as practice working out the problems that we started out with yesterday. Okay, so you got to be able to, folks, be able to. You have to be able to take a graph, a position time graph, and be able to interpret how the object is moving, the motion of that object as it is described in the position time graph. And from that position time graph, we saw then that the slope of a line on that position time graph gives us then the speed, or if we factor in the direction, the velocity of an object as it moves as well. Okay, so that formula, what we were able to obtain yesterday, and what we were able to use yesterday from this one then, is that we were able to show then yesterday that the slope, and remember we saw this with the slope then is described as the rise of the run. We're able to describe then the velocity here, or the speed, and so speed is the velocity without direction, is described then as the change in the position of an object over change in time. We were able to derive this equation here because this is the slope. This is the slope of the line. The position over the change of position over the change of time, which is the rise or the run. This is the change in y, the y-axis, or the change over in the x-axis. And this equation we were able to derive. We were able to derive this equation from the position time graph. Okay. Okay. So what can we do with these equations? And what's the whole idea behind graphing? What's the whole idea behind obtaining these equations anyway? Well, we can use the equations then, and we can use the graph to predict the motion, predict where the object will end up after a certain amount of time if it's moving at a certain speed, or how much time it took to cover a certain distance at a certain speed. So the idea behind, in physics, the idea behind getting an equation is that we can use that equation to make predictions. Okay, and so we can make predictions about motion in this case then, and that's the reason why when you take a look at physics, there's so much math and there's so many formulas that are involved in physics, because each formula then is meant to describe a certain physical phenomenon that's being observed at that point. Okay? All right, so that's where we came up with this equation from. And so we were able to apply this equation here then to calculating for a problem like this. So in this particular problem here, what we did yesterday is we were trying to predict how far an object moves, how far this particular bike moves, if it is moving at this speed here, okay, and it's moving for this time interval here. And we were able to make this prediction here because of this particular formula. This particular formula we were able to get that again from an analysis of the position time graph for the motion of an object. Okay? And so from here, so for what we can do then is, instead of having to plot the motion here, if we're only given these two pieces of information, we can now, because we have this formula, make this prediction here about the how far it moves. Okay? And so that's the idea behind coming up with formulas, and that's the reason why in physics we want to boil everything down to its very very simple symbols. We can represent that in terms of these formulas. Okay. All right. So let's go ahead then and let's practice this. So we worked out this problem yesterday. Okay. So let's go ahead and let's do a problem here. I want you to take a couple minutes to set up this problem here. So let's go ahead and work this out. Take about 5 minutes to work out this problem. And then at the end of 5 minutes, make sure you type in your answer, and then make sure you write it on your paper that you're going to submit, and then I'll work it out for you. So take about 5 minutes to work out, a little less than 5 minutes to work out this problem. Okay, go ahead and get started. Okay, let's go ahead and let's take a look at what we have here. Okay, so first of all, let's go ahead and analyze what we have. Let's go ahead and highlight what we have. We have the object here is the jogger. Okay, we were told then that the jogger runs at a constant rate of 10 meters for every second. Let's make sure we understand what that is meant for in just a moment. Okay, we are told then that the jogger starts at the origin, at the point that we have arbitrarily set as being 0, and it runs in the positive x direction for this time interval here for about 1 hour. Okay, all right, so that's what we were told. The question that we were asked to find then, to calculate for, is where, which means that we were trying to find the position of the runner after not 1 hour, and not after 3,600 seconds, but after 5 seconds and after 15 seconds. Okay, so let's make sure we are clear on what we have here. Okay, so we have here an object that's running in one dimension. Okay, so running along the positive x-axis, starting at 0 here. So that's our 0 meters. So our object starts here. So there's our runner. Okay, and he starts to run. Okay, he starts to run in the positive x direction, so he starts to move towards the right. And again, direction is arbitrary here. We get to decide what direction we're going to deal with, but if we stick with convention, positive will be to the right along an x-axis, negative will be to the left, positive along the y-axis will be up, and negative will be down. If we stick with convention, we save ourselves some problems later on with direction. Okay. All right, so we were told then that he runs for a total time of, if we indicate time down here, okay, so this is the displacement here. This is going to be 0. This is going to be our displacement, okay, and this will be our time. So we'll indicate the time here. Okay, so he runs for a total of 3,600 seconds. Okay, however, we're not asked to find how far he moves at the end of 3,600 seconds. We're asked to find then how far he moves at the end of 5 seconds, and we'll call that T1. That's at the end of 5 seconds. Okay, how far has he moved? So we're trying to find that distance here, okay, and we'll call that x1. Okay, and then we're also asked to find that at 15 seconds, at the 15-second point, which we'll call t2, how far has he run at that point? We are not asked to find his total distance. Okay, so hopefully in your work you were able to differentiate that and see that. Okay, so with that said, make sure you get this down. Okay, and I'm going to clear the drawing here, and let's move down one, and I want to work this problem out for you. Okay, all right, so let's go ahead then, and let's write down what we have. Okay, let's go ahead and write down what we have. Okay, so the formula that we're going to use, and we have this. Okay, this is, since there's direction, we're going to be using velocity. Velocity is equal to the displacement, okay, over the total time interval. So this is the formula that we're going to use to solve for both of these. Okay, so let's go ahead and solve for the first one. In the first one, then, we were given a time interval of 5 seconds. Okay, so the first time interval is 5 seconds. Okay, so we were given that. Okay, we were asked to solve for how far the object moves. Okay, so that's going to be total displacement. Okay, so we're asked to solve for that. Okay. So which means then, I'm sorry, let me go ahead and write this here. Which means then we will have to find an equation to solve for that one. So this is the formula that we're going to use. We have to find the equation to solve for that one. Which means then we have the time. This is the time interval. Okay, we've solved for this. We need the velocity. Okay, and do they give us that velocity? Yes, they mentioned the rate at the very beginning. They mentioned the rate as being 10 meters per second. And so the velocity then is positive 10 meters per second, moving in the positive direction. So this you had to be able to read in the problem, and this they gave it to you. Okay, so they actually give us both of those. All right, so with that said then, let's rearrange that formula there to obtain the displacement. So let's get the equation that we need to solve for that. So if you notice here, multiply both sides by the delta t, change in time, we end up with this equation here to solve for it. Okay. And I always suggest, I would advise that you do that. And if you're, for those of you folks who are moving on in physics, this is what you'll have to get used to as well. Okay, so make sure then you identify what is given. So write down what you're given, identify what you're going to solve for, and then set up the equation that you will need to solve for that particular unknown, which means then you set the unknown all by itself. Okay. All right, so with that said, let's go ahead and plug in what we have here. So the velocity is 10 meters per second. We're going to multiply that by the time interval here, which is going to be a 5-second time interval. Okay. And so with that said then, to one significant figure, our answer, hopefully you recognize this then, it's going to be 50. And the units, if the seconds units cancel out, the unit should be 50 meters. Okay. All right. So that's for the first one. For the second one, let's go ahead and write that. Let's just quickly work that out again. The time interval that we're asked to look at now is 15 seconds. So we're asked to find how far he moves at the 15-second time interval. So displacement after that, that's what we're solving for. And again, the velocity is going to be the same. It's 10 meters per second. Rearranging the equation to solve for delta x2, the displacement, the second displacement. We're going to use the velocity. He's still moving at that same constant velocity. And this time the change in time interval will be different. So let's go ahead and plug that in and solve for it. So we have a 10 meter per second velocity. He moves at a rate of, and then he moves for 15 seconds. Sorry, let's go put that in there. And so therefore, if you plug this in, he would have ran a total of 150 meters, but round that off to 1 sig fig, so 200 meters is how far he ran, okay? All right, so what we did here then is from the problem, we identified what we were given, we identified what we were solving for, we identified then the formula that we're going to use, okay, and then we went ahead then and we rearranged that formula in order to get the equation that we would need in order to solve for unknown. Okay, so that's the procedure that you would use in order to get your answers for these problems here. Okay. All right, let's go ahead then. Let's you got that. Let's do one more. Let's practice another problem here. Okay. Okay. Try number 3 here in your problems. Again, take about 5 minutes to work on this problem here, and then I want to work out this problem for you when you come back. Okay, so go ahead, take about 4 or 5 minutes to work out this problem. Okay, set it up, and then try to solve for it, and then when you get back, I'll work it out for you. Okay, go ahead and get started. Okay. Let's go ahead and let's take a look at what we were given here. Okay, let's go ahead and let's take a look at what we're given here and identify what they're asking to solve for. Okay, so we have two objects moving. We are comparing 2 objects now. Okay, we got our 2 cars here. Okay, we are told then that they start out at some position, they end up at another position. We are told that we have this distance here. Okay, and this distance here represents the distance the beaches from school. Okay, we are told then a time, okay, a time, not a time interval, but a time that this car leaves. Okay, we are told then where this car A starts from. It starts at a distance that's 10 kilometers closer, and that it's moving at this rate here at 40 kilometers per hour rate. Okay, then our second object here. Okay, we're told then that it starts from this position. Okay, and it starts at this time here, not the time interval, but this time here. And so the question then is when, and I'm sorry, and it's moving at this rate here. Okay. The question is what time, and what time does each car get to the beach? Okay. All right, let's go ahead then and let's set this up. Okay, let me clear this up. All right. So I like doing this problem here because it gives me a chance to point out one other thing that you should probably do when you do these problems, and that is make sure you draw simple pictures. Draw real simple pictures to help you do this. Okay. All right. So again, what we're going to do is we're going to use velocity or speed here. So we're going to use this formula here because we're asked about displacement and we're asked about time. Okay. So this is the formula that we're going to use to calculate for this. Okay. All right. So let's go ahead and let's draw our simple picture. Okay. So we have two objects. Okay. Okay. I'll call this car B. So this is car B. And again, when you draw these pictures, they do not have to be elaborate. Okay. They can be pretty straightforward. And I'll call this car A. Okay. All right. So the position here, and we'll call this position, and we'll trace this along the x-axis. Okay, so this position here, I'm sorry, let me just go ahead and draw a line here really quickly. Okay. So this position here, we will refer to as 0. Okay, so this position here, x is going to be 0. That's our origin. Okay. And so let's go ahead and draw the y-axis real quickly. I'm sorry, the x-axis, and then indicate then the direction of motion. Okay, so and we'll say then at this point here, this is the beach. Okay, and we'll call then x equal to 0 kilometers here. Kilometers here. This is the school, so we'll indicate this position then as being where the school is located, okay? And we'll call this then the position where the beach is located. And we were told in the problem that the beach is located 100 Yeah, 100, I'm sorry, 50 kilometers away from the school. Okay, so we're told then that the beach is located 50 kilometers away from the school. Okay, all right. So with that said, then let's go ahead and continue to write down what we have here. Okay, we were told then, and sorry, let me go ahead and draw an arrow here. We were told then that car A starts out and it moves towards the beach. Okay, so it moves towards the beach, and we were told then that car A, okay, moves at a velocity. Its speed for car A is 40 kilometers per hour. Okay, so that's the speed at which, how do we know it's the speed? Look at the units, folks, the rate, length over time. Okay, so the units here are the units for speed or velocity as well. Okay, all right, so with that said then, if we were told then that the car A starts at a position that is 10 kilometers closer to the beach. So it moves the total distance to get from its starting position here. So it does not start at 0. Okay, hopefully you see then that based on what the information we're given, that it starts at a position. So we trace this here. It starts at a position that is 10 kilometers from the school because it's 40 meters close. So it starts, the starting position for car A then is going to be 10 kilometers. And so therefore it moves a total distance of 40 kilometers to get to the beach. Okay. All right. Now, in terms of the times, let's go ahead and draw the time scale. And let's do that real quickly. Draw the time scale here, okay, for both. Okay. So if this is position here, we have time on the bottom. Okay. So let's go ahead and do this. So this is then we indicate then T is equal to 0 hours. Okay. Okay. All right. So we'll indicate that in just a moment. Okay. So with that said, then we have the car here, car A starting at a time. So they give us an actual time here of 12 o'clock. Okay. Of 12 p.m. That's when it starts out. Okay. So that's when it starts out for that. Okay. All right. So let's go ahead and do the same thing for car B. And I'm running a little low on time here. So what we'll do is I'm going to ask you to finish this up. I'll set up the problem for you, and then I'll ask you to finish it up. Okay. Okay, so car B then starts out at the school and it moves all the way to the beach here. Okay, and so with that said, then let's write down what we were given. Okay, therefore, then we are told that the speed for car, so this is for car A, the speed of car A, and the displacement for car A. Okay, so the velocity, the speed for car B, we're told that it moves at a rate of 100 kilometers per hour. Okay, it moves at 100 kilometers per hour. And since it starts at the school, it starts at 0, its total distance that it covers is going to be 50 kilometers. Okay, and it starts out, and we were told then that it starts out a little bit later. Oh, excuse me, folks. Excuse me. And it starts out at a time at 12:30 p.m. Okay. Okay, so what I have here, what I've done for you is I've drawn for you and labeled for you everything that we were going to solve, that we need to solve for this. And so hopefully you recognize here that in each case here, we need to find then the time interval. We're given the velocity here, we're given the speed, we're given the distance traveled. So essentially in each one of these here, we are solving for the time interval. So setting up the equation here then to help us solve for that then, it's going to be displacement over velocity. So that will be for the time interval for car B. The time interval for car A then will be the same thing. And I'm sorry, this will be for B, velocity of B. This will be the displacement for car A over the velocity for car A. And this calculation will give us the time interval. Okay, so go ahead and what I'd like you to do to finish out the assignment here, I want you to make sure then that you write this out, draw this picture on your paper, okay, and then write out your answer here, okay, hopefully, and then compare it to what you have. So understand this, and just I'm gonna leave you with this, okay. What you're done with when you are finished with here, what you are given, what you solve for is the time interval. But what the question asks you for is the time. What time does both cars arrive at the beach? Okay, so keep that in mind as you work this out. Make sure you write down the answer, and then we'll start with this problem tomorrow. Okay, so make sure you draw this diagram on your paper, solve for it, and then we'll start with this tomorrow in class. Okay, all right. Very good, folks. I will stop on by after school today if you have any questions, 1:15, 1:30 to 2:30, okay, if you have any questions. And then if not, I'll finish going over this for you tomorrow, okay? I'll see you folks soon.